Okay, weighted graphs are, we've made these trees from graphs before, but what was the point? Why make a spanning tree? Well, the reason for that is that sometimes we're connecting, for example, pipelines or routes or plane routes, bus routes, whatever, and they take different amounts of money or time to take place. Well, if you can figure out what it costs in time or money to traverse between these two, you might be interested in two questions. One is, what is the minimum weight, I guess we'd say, the minimum weight for A, connecting all hubs or vertices? And what's the other question that we might ask? Yeah, just trip from one vertice A to whatever. We'll say E. Okay? And this is where it gets good. This is where it gets interesting. And the applications are huge. This is the way the world is. Multiple opportunities. How do they save money by working out their routes? You might want to think about FedEx. Have we ever talked about FedEx in here? Their innovation was send everything to Atlanta, and then from Atlanta go to hubs and send out, versus having hubs in every city going everywhere. You all go to Atlanta, and then from there it goes to those different places. Ingenious. And it probably came from mathematics similar to this. This connecting all vertices is when we use Kruskal, and when we're using the minimum distance, it's the Dijkstra. Oh, IJK, that's easy to remember. Okay, so we're going to do Kruskal's algorithm first. Kruskal is the one who's trying to help us connect all of the vertices with least weight. And the way that you start is you go to the least weight edge first. Then you choose the edge remaining that complete the cycle or complete the tree, and go with the ones that have the least. And you just keep going, n-1 edges. What they're saying here is that, let's take an example here. Which one of these is the shortest, least weight? FG. So you start with that, FG. Okay? And we want a minimum spanning tree. So we want to get to each and every vertice. So from F or G, which is the shortest distance to E? Shortest weight. Yep, EG. Okay? We want to stay away from DG, don't we? What's the least weight to get to D? Either from E or G, which is shortest? Or least? E to D. How about from E to C? Or D to C? Doesn't matter. And that happens sometimes. That's okay. So you can do CD or EC. And then we have two more to get to. We want to get to A, and we want to get to B. Now, what is the shortest way to get to B? What's that? Yeah, so you're going to have to go to A for sure. And now, to get to B, do you go the 6 or do you go the 8? Which will be shorter? The 6. So that's going to be your least weight spanning tree. And you can look at other combinations. That's the least. So what you do, we started with the shortest, and then we go to vertices with the least weight, and then we just keep going until we get to the total, and then you got to add those up. 6 plus 3 plus 5 plus 3 plus 4 plus 2, which is 9, and 8 is 17, and 6 is 23. That's the least spanning tree. Okay. Sound good? I like those. Those are easy. The next one's a little tougher. And that has to do with the route. But before we do that, they do have the weighted graph. You can do the comp, or what was the what's that? Adjacency table. We're going to have a Cayley table when we do group theory. But yeah, this is good. A, B, C, D, A, B, C, D. And when you set these up, notice that you have this symmetry through here, and that this top is the same as the bottom. So let's just ignore one or the other. We'll ignore the bottom. And now you can see this making a lot of sense. The 2 to the 6, 2 to the 3, 2 to 4, right? And so from B here, we'd go from 2, and then we go to, see, actually, to get here, we don't want to do that. We want 2 to 3. We want 2 to 6 or 2 to 4? 2 to 4. And then what's the one we want to do? 2 to 3 or 2 to 5? I'm sorry. To get to A, are you going to go, yeah, you're going to pick the 3 here. And so there's your spanning tree. So it's 2 to 3, 2 to 4, yeah. And so when you add those up, you're going to get 5, 9. And there you got it. Is this different? Do this one real quick. So what we did is we filled out the table, and then we started it. The shortest was C, C to D, D to E, E to A to B, because those are the shortest. But the question was asked, how does the table even help? And I guess what you could do is you could say, all right, C, D, this is the least, right? And then you can see this adjacent, you're going to be able to get to 4. You're going to get to 5. Yeah, so, right, though? Did I do that right? This 3 is adjacent to the 4. The 4 is adjacent to the 5.
You just have to cover every edge.
Oh. So you're doing these? Is that what you're doing? I don't think that can. I don't. It works here. I don't know if it always works, though.
I mean, you have to cover everything. You know you have to.
I think what they're doing is they're saying, okay, when you look at these, they show up on here, but I'm not sure if you can say the weighted graph helps you do it. Mm-hmm. Right, right. Okay, last one. Now, the minimum connector problem. This is going to drive you crazy a little bit, but it's not too bad. Let's say we want to go from A to D. Tell me, what is the shortest route in weight going to be? Is it just going to be straight across 23? You might try that, though, 23. See if you can beat 23. You can go up here, and then what? And then down to G, that's 6, then what? And then go to...
The 11 would be shorter than that.
No, I think the 10 will be left. That's all right. And so this is going to be 6, and 10 is 16, 17, 18. Can you beat 18?
Yeah, you just go down the bottom.
Oh, and you could just go 10, 6, 2. That'll do it as well. And that happens. Sometimes you'll have multiple ways of having that minimum weighted path. But again, the computer can exhaust all these, but there's a better way, and it's an algorithm that has been programmed so that you can find these minimum weight routes, and we're going to look through it. Now, this is a little challenging, but it's going to make sense. The first thing you do is you start at your starting point. Let's say you're going from A, I think it was, to D, was it? Okay. So what you do is you assign a 0 to the vertex. And they put it after. It doesn't matter when you put it. And then to make that permanent, you put a box around it. Every time we draw a box, that means that we're leaving it reasonably permanent. Okay? We draw a box around the vertex, show the label is permanent. Okay. Now what we're going to do is from that point, go to all the other possibilities and then write that number down. Okay? And so you go to the possibilities, write it down, and then choose the least of all of them and box it. Okay? So going through this example here, we start with A. We're going to D. You go to each of these, 10, 8, and 4. B is the one I put a 4 and I box it because that's the least. I'll show you. So then after B, notice that you could go back to A, which you wouldn't want to do, and go to those. Then you take 4, add 3, you get 7. 4, add 2, and get 6. Okay? Now remember, when we did this before, we put an 8 here next to G and a 10 here. But if you go here and then back, it's actually going to be less. So we cross out the 8, and then we put the 6 below it. So which is the least of these? C7 or C6? Or G6? Which is the least? G6. So then I put a box around that. Now here's where it gets kind of ugly. Now you, from here, go to all of those places. And so here, if you go 6 and 8, you're going to have 14, which you wouldn't even write down because you had a 7 already. Add 15 here. 6 and 15 is 21. And then 6 and 4 is 10, so you don't even need to write that down if you don't want to. And then 6 and 11 is going to be 17. Which is the least of these? 17, 21, 14. Which is the least? 10 here? Yeah, 10. So 10 is the one that's the least. Okay? So then I put a box wherever it wins the least amount. And then from there, you go out. And now we go 10 and 6. 10 and 6 now is going to be 16, not 17. And going back is not going to make any sense. And so now you go 16 and 2 from here. I box this. 16 and 2 is going to be 18. All the rest, well, 16 and 2 is going to be 18. So then I cross this one out. Well, you can with an easy one, but the bigger they are, this is how they program the computers to do it. Then what they'll do is anything that isn't boxed, see if there are any that we missed, and then put those in and see if that total gets more or less than 18. But it looks like 18 is going to be my winner. So we had D, backtrack to E, backtrack to what? F. And then F, you could have gone 4, 2, 4, or you could just go A to F, E to D. We also did G, backed up from B, and backed up from A. So that's the other method of doing it. And that's the Dijkstra method, algorithm. Let's do one homework one so that you kind of see. I think you'll be fine with the Kruskal part, but it's the Dijkstra one is the one that's the tougher of them. Let's do this number one together. Okay, so A, you're going to put a 4 next to the B. You're going to put an 8 next to the G. Put an 11 next to this one. Which is the least?
Oh, there. Okay.
Which is the least? 4. So then you put a box around it. Okay, now from there, 4 and 2 is 6. So we cross this one out. 4 and 6 is 10. And which is the least of those two? 6. So we put a box around G. Now from there, we're going to go 6 and 4 is 10. 6 and 1, oh, is that 11? Shoot, that's 17. And then 14, 6, 14 is 20. 6 and 8 is 14. I don't need to write that. And so what's the least of all of these? 10, yep. 10. Okay, and you can put this 10 as well, right? Now when I add this 13 to get here, you get 23, which I wouldn't even write down. From this 10, you go 6, that's going to give me 16. Okay, that's better. And what's 16 and 5? 21, not better. So it looks like your answer for this one is going to be 20 is the minimum connector. You go D, and before that is going to be my, what was it, E? No, it was C.
No, you just went to the middle.
It was A, B, G, G.
Well, let's double check here. We got 6 and 14, yeah, so that was G. And then it was B, and then it was A. And if you want to, you can write the numbers below it. 4, 6, no, 4, 2, and 14. Gives you 20. And that's Dijkstra. Those are the two methods you're going to practice.